Okay, so today we are going to be working on IXL, and we are going to be completing four little activities: IXL S2, 3, 20, and 21 today. So what I'm going to do is go through each little one and show you how to solve them, and then you will use the rest of this time for class to finish out all of the problems here. So this says the table shows a function. Is this function linear or nonlinear? In order to be a linear function, what has to happen in the table is that the numbers are increasing and decreasing by the same thing. So let's look at x versus y. So I can look at x, it goes from 0 to 1, 1 to 2. So 0 to 1 is an increase of 1, and 1 to 2 is an increase of 1. Looking at y, it starts at 3, and it increases from 3 to 10, that's an increase of 7, and 10 to 17. That's an increase of 7 as well. Well, slope is when you have a constant rate of change, meaning that your change in y, how much the y increases or decreases, is in constant with the change in x. It doesn't mean it has to increase or decrease by the same number. So what happens is y increased by 7 each time, while x increased by 1. And because they increased by the same ratio, this increased by 7, this increased by 1. So the increase was 7 over 1. This is a 7 over 1. That makes it linear. Okay, the next one, looking at this one, 3 to 4 is an increase of 1, 4 to 5 is an increase of 1, and then 18 to 13 is a decrease of 5, 13 to 8 is a decrease of 5. So this decreased 5 for every increase of 1, this decreased 5 for every increase of 1. Because they decrease or increase by the same ratio, this is also linear. Okay, so that's how you would complete S2. Moving back to the S problems, S3, finding slope of a graph. So to find the slope of the graph, you look at the graph and pick points that are perfect. So I'm looking at this point right here. This point is 0, 40. I can see that because it's right here at 40 on the y-axis. And then you're going to want to pick points that are perfect, not estimations. Like I'm not going to choose this point. This point is 10, comma, I don't know, something in between 50 and 60. I'm not going to use that point. So I keep going through the line to where I find a point that's perfect, and here's a perfect point right here. This point is at 20 on the x-axis and 70 on the y-axis. So what you would do here is you could write the 2 points out. So the 2 points are 0, 40, and this is not where you're going to write your answer. I'm just typing this in. 0, 40, and 20, 70. And you could use the slope formula. The slope formula says take the y's and subtract them. 70 minus 40 is 30. And then take the x's and subtract them. 20 minus 0 is 20. So this is going to be 30 over 20, and then simplify that. Or you can use the rise over run idea by looking at how far it goes up versus over. Well, to get from 40, we're looking at this point to this point, it goes from 40 up to 70, so that's an increase of 30. And then it goes from 0 here on x to 20, that's an increase of 20. So 30 over 20 is the slope. However, it wants us to simplify this answer as a proper fraction, improper fraction, or integer, meaning we're going to simplify this. 30 over 20, 30 can be divided by 10, and 20 can be divided by 10. This simplifies to be 3 over 2. So the slope is 3 over 2. Okay, looking at the next one. Finding the slope of this, we need to find points that are perfect. This point right here, 0, comma, it's somewhere in between 4 and 5. It's not perfect, so I'm not going to use that point. I can use this point, though. 1, 5 is a point I can use. And looking at this, these are all estimations, but this point is good. I can use this point as well, 4, 6. So you can either write out the point 1, 5 and 4, 6 and use the slope formula, or look at the rise over the run. To get from this point to this point, I have to go up 1 unit. That's an increase of 1. And I have to go over 1, 2, 3 units. So that means the slope would be 1 over 3. Since the rise is a positive 1, the run is 3, 1 over 3 is simplified. That would be the answer. Okay, that's how you would do that one. Looking back at these skills, going down to S, the next one we're going to do is equations of horizontal and vertical lines, so S20. So looking at this graph, we are either going to write the equation as y equals or x equals. This is a vertical line. Vertical lines always start with x equals, and it's wherever it equals on the x. All of these points on this line all start with 6 as the x number. Like this point here is 6, 0. This point here is 6, 1. This is 6, 2, 6, 3, 6, 4, and so on. Every single point on this line has 6 as the x number, so the equation is x equals 6. This says, is the graph of this equation a horizontal or vertical line? Anything that starts with x is a vertical line. Okay, this is going to the same thing, vertical line. But I just want to show you a horizontal line just so we can be sure. Here's a horizontal line. A horizontal line, it goes like this from left to right, and it's at -10 on the y-axis. Horizontal lines start with y equals, so this would be y equals -10. Okay, so that's a pretty easy one. Going back to the last one that I'm assigning for today is S21, graphing a horizontal or vertical line. So it says select points on the graph to graph. So y equals -6. What you do is you go to the y-axis and you go to -6, and you graph any points along this line. So any points, I just chose that one and that one. It creates the line for you, and then submit. There's your equation. Y equals 5. I know this is a horizontal line again, so I'm going to just choose this one and then this one randomly. It'll make the line for you, and then hit submit, and you're done. I'll do one more, x equals 10. X equals is a vertical line, so I go over here to 10 on the x-axis, and that's what it would look like, submit. So that one's pretty easy. So today you are going to be working on 4 IXLs. They should be pretty quick and easy, I'm hoping. It's S2 and S3 are pretty hard, but I think you can figure it out. If we struggle with S3, let me know. And then S20 and S21.